Believe it or not, electrochemistry helps us to decide whether or not a metal will dissolve in acid. And the reason for this is because H plus is reduced to hydrogen gas, and our metal that we're trying to dissolve is oxidized into the ion. And so if we look at our table of standard reduction potentials, we can decide if a metal will dissolve or not based on the fact of if it's located below our H plus to H2 reaction, which is our zero potential reaction. So if it's located below that, the metal will dissolve. If it's located above that, that means that it will not dissolve in acid. There is one exception to this, however, and that is nitric acid. And so nitric acid is much further up the table with a potential of 0.96. And so nitric acid will dissolve many metals. Anything that's below nitric acid on the table will dissolve. There are a couple of exceptions. So gold is above it, platinum as well. And so we can use a mixture of nitric and hydrochloric acid in a 3-to-1 ratio. 1 part nitric acid, 3 parts hydrochloric acid, and this is called aqua regia, and this will help to dissolve even gold and platinum. Here's a practice. Which of the following metals will dissolve in acetic acid? Write the reactions. Pause the video and give this a try. So if we notice our acid, our H plus to H2, is located in the middle of the table. So the metals that are going to dissolve are going to be metals that are found below it on the table. So if we look at silver, silver is above it, copper is above it, but iron and chromium are below it. And so these will dissolve in our acetic acid. And for our reaction, we're going to take our iron plus our acetic acid. Remember, when it's an acid, it's always aqueous. And now we need to balance it because this is not balanced. So we are going to have to, this says we need 3 acetates. But that is not going to work with our hydrogen because we also need 2 hydrogen. So we're going to go to the least common multiple of 6. Okay. So if we have 6, that means that we need 2 of our iron acetate because there's 3. 3 times 2 gives us 6. Okay, if we put 6 in front of the hydrogen, that means we need 3 of the H2. This would be a gas. And then we need to balance our iron, so it would be 2 iron. Now how about the chromium? So chromium, again, has a +3 charge. That's how we know we needed 3 acetates. again, because it's a +3, we're going to need 3 acetate ions because they're each a +1. Okay, and to balance it again, we're going to need 3 acetates, but we'll also need 2 hydrogens. So again, least common multiple, we put a 6. Okay, so to get 6 acetates, we need a 2 in front of our chromium on our product side. 2 in front of the chromium to balance the chromium. And then to make 6 H2, or to make 6 hydrogens, we need 3 H2. And so this would be our balanced chemical reactions for iron and chromium to dissolve.